Hello and welcome to Chapter 21. This is the last chapter we'll be covering in the class, and here we'll be looking at a specific application of spectrophotometry where we look at atoms instead of looking at molecular signals. So Chapter 21 is all about atomic spectroscopy, and there are several different ways we can do atomic spectroscopy. We'll be looking at atomic absorption spectroscopy, atomic emission spectroscopy, and even there's a possibility of doing fluorescence spectroscopy with atoms. And so this is a very common technique used in analytical chemistry. And the essential idea is that we take our sample. So often this is an aqueous sample, as we're often measuring in analytical chemistry. So we have this in some sort of liquid solution, and then we take that sample and burn it. And we'll talk about there's a few different ways we can do this. So that everything is atomized. We want to break everything down into its atomic constituents, and then we do spectroscopy on this sample. So we send in our light. We have a detector on the other side. I've left out the monochromator, but there's still going to be a monochromator present here as well. All right, and so we break our sample apart into its constituent atoms and measure those atoms separately. Now, of course, this is all going to be UV visible spectroscopy because atoms don't have any vibrational motion or rotational motion, so everything's electronic energy levels that we're going to be looking at. So all of the equipment for atomic spectroscopy is going to be in the invisible or ultraviolet. Okay, and so why do this? What are the advantages of of burning our sample, right? And atomizing everything. So some of the main advantages. One is that atomic spectroscopy can be much more sensitive than just traditional spectrophotometry. So atomic spectroscopy is often used to measure things that are present at part per million or part per billion level, depending on which specific technique we're looking at, which can be difficult to do with traditional spectrophotometry with the regular UV vis instrument. Another big advantage is that it's very easy to distinguish different elements. You can be pretty certain that what you're looking at is what you're trying to measure. So when you break everything into its atoms, there are distinct absorption features or emission features that are specific to that atom, and you can tell them apart pretty easily. And we'll go into why that is in comparison to something that's in the liquid phase. One other advantage is that we can measure many elements at once, depending on the technique. So we don't have to be limited to just looking at one thing at a time. And because you do the same thing every time, you burn it, you atomize it, this is easy to automate. Now, of course, there are disadvantages to the technique as well, so we're just going to lead off with both the advantages and disadvantages. So some of the disadvantages, of course, the biggest one is that if what you're interested in measuring is actually a molecule, you can't do it. So there's no way to measure molecules. Now, if what you're trying to measure is part of a molecule, and the molecule is the only thing that contains that in your sample, you could still use this. So say, for example, you're looking at hemoglobin and iron is in it. You can measure the iron to get an idea of how much hemoglobin there was if there's nothing else that contains iron in your sample. Another big disadvantage is that the sample must be destroyed to analyze it. So this is what's known as a destructive technique. That's just the nature of it, right? By burning it up, you are destroying it. And the instrumentation is fairly expensive. Not ridiculously so, though, depending on the specific type of atomic spectroscopy. But it is more expensive than, say, just a UV vis spectrometer because of some of these extra things you have to add in. All right, so in the next video, we'll look at the three main ways that atomic spectroscopy can be done and sort of what are the similarities and differences between them.